You know the feeling, right? Your users are just sitting there staring at endless loading screens because your backend is completely choked, struggling to keep up with demand. Well, if your application relies entirely on a traditional database doing all the heavy lifting, you're probably hitting a massive speed limit.
So welcome to today's Explainer. I am so thrilled you're here because we're going to dive into exactly how to transform your architecture with the ultimate speed solution. We're talking about Redis, a wildly fast in-memory data storage platform that completely rewrites the rules of backend performance.
Here's our roadmap for today's Explainer. We're going to cover the need for in-memory speed, core features and data types, real-time apps and queues, Redis versus the world, and finally, production warnings and security.
All right, let's jump right into Section 1, the need for in-memory speed, or breaking that disk bottleneck. Look, standard databases are absolutely incredible, but fetching data from physical disks severely bottlenecks performance the second your traffic spikes. Redis is the solution to that exact problem. It stands for Remote Dictionary Server, and it's this incredibly fast in-memory data store. We use it for caching, managing user sessions, queues, counters, and powering all those snappy real-time application features. And the reason it works so well? It keeps your data primarily in your system's RAM. Since RAM is just orders of magnitude faster than a traditional hard disk, Redis gives you those lightning-fast millisecond response times.
So how does this actually work in practice? Let's look at the cache aside pattern. Imagine a user opens their profile. First, your backend checks Redis. If the data's already there, boom, instant response. If it's missing, no big deal. The backend just queries your slower primary database, but crucially, it then saves that result right back into Redis for next time. It's like having a super fast assistant so your primary database doesn't get overloaded by the same simple requests over and over again.
But hold on, there is a catch. Because memory space is super limited and honestly pretty expensive, you have to set what's called a TTL, or time to live. It is an absolutely crucial safety measure. A TTL is basically just an expiration timer set on your keys. Like, you can force a one-time password code to magically expire and delete itself after 300 seconds. Without a TTL strategy in place, your Redis memory will just grow infinitely until your entire server completely crashes. And nobody wants that.
Moving right along to Section 2, core features and data types, the Swiss Army knife.
What's really fascinating is that modern Redis has evolved way beyond just being a basic key-value store. It's a highly versatile toolkit. It's literally like a Swiss Army knife where you match the exact blade to your engineering problem. Need to cache a simple configuration or an OTP? Just throw it in a string. Storing a multi-field user profile? Grab a hash. Tracking recent user activity? A list is perfect for that. Or say you're building a massive multiplayer gaming leaderboard. You'd reach for a sorted set because it automatically ranks unique values by score. You literally just match the data type to your use case and you get maximum speed.
And get this, building on that versatility, Redis is now fully AI ready. Modern Redis supports storing complex vector embeddings, running vector searches, RAG retrieval, and similarity matching. So it's totally equipped for fast AI application features, acting as this incredibly low-latency memory bank for large language models. Pretty cool, right?
Okay, Section 3, real-time apps and queues, active data handling.
Let's talk about active moving data. For background jobs, think heavy tasks like sending out a massive batch of welcome emails or generating a huge PDF report. Redis acts as the perfect middleman. Your API instantly pushes the job to a Redis queue and immediately tells the user, yep, it's done. Then, an independent background worker picks up the job and silently processes it. This setup keeps your API incredibly snappy and prevents those long tasks from freezing up your user screens.
Redis also gives you two main ways to handle messaging, and you definitely need to know the difference. Redis Pub Sub is fantastic for live updates, like a live chat room, but it uses at most once delivery, meaning if a subscriber is offline, they miss the message forever. On the flip side, Redis Streams acts as an append-only log. Streams safely store messages in order so that worker applications can reliably process them later.
Now picture the number 5 for a second. Imagine you want to allow only 5 OTP login requests per phone number per hour just to prevent abuse. By utilizing its incredibly fast in-memory counters, Redis can instantly check and increment a user's count, immediately rejecting request number 6. This is rate limiting in action. It's an effortless way to protect your API from spam and brute force attacks.
Which brings us to Section 4, Redis versus the world, choosing the right tool.
We all know software architecture is all about trade-offs. So first up, Redis versus Postgres.
The absolute golden rule here is never replace your primary database with Redis. Postgres is durable, permanent, and designed for disk-first relational data, stuff like financial records. You gotta keep Postgres as your permanent source of truth, and safely layer Redis on top of it for volatile, high-speed, temporary state.
Next up, how does Redis Streams stack up against Kafka for event processing? Well, Redis Streams is fantastic, simpler and great for smaller internal background jobs. But Kafka is a totally different beast. It's significantly stronger when you need a high-throughput, massive-scale, durable event pipeline for a sprawling microservice architecture.
A quick side note here about the ecosystem. In 2024, Redis actually changed its open-source licensing model. So if strict open-source licensing matters heavily to your company or your compliance team, you should really look into Valkey. It's a Linux Foundation-backed, open-source fork that acts as a highly compatible alternative to modern Redis, and it uses the exact same commands your developers already know.
Finally, let's wrap up with Section 5, Production Warnings and Security, setting up guardrails.
Look, we can't finish this explainer without a harsh reality check, unless you actually enjoy your pager going off at 3 a.m. There are some common catastrophic mistakes teams make, from trying to use Redis as an isolated primary database, to completely forgetting to configure memory limits and eviction policies. And please, for the love of everything, avoid trying to cram massive JSON blobs into poorly named keys. It will completely destroy your network throughput. Redis is incredibly fast, but careless design will still break production. But the absolute biggest, scariest red flag of all is exposure. You have to rigorously protect your Redis instances. A public Redis instance left open on the internet is not just a potential risk, it will become a serious security incident. You must enforce strict authentication, TLS encryption, and hide the whole thing entirely behind private network firewalls to avoid devastating data leaks.
Ultimately, managing Redis means you gotta watch your metrics like a hawk. Are you seeing endless memory growth? What about unexplained CPU usage spikes? Most importantly, check your cache hit rate. If your cache hit rate is constantly low, it means your backend is basically just bypassing Redis and going straight to the primary database anyway, which means your entire caching strategy is failing you.
I think this quote perfectly summarizes everything we've broken down today about how to correctly position this technology. Redis is a high-speed, in-memory data platform used to make applications faster and support real-time backend features. It is an absolutely incredible supporting actor, but it should not be cast as the only star of your data show.
So I'll leave you with this question. Is your caching strategy actually accelerating your app, or is it secretly just maxing out your expensive memory limits with useless data? I challenge you to audit your own backend architecture today with that thought in mind, and see if your setup is truly optimized for speed. Thank you so much for joining me for this explainer, and keep building.